Hi, my name is Edward Lind, and I would like to demo my assignment 1 for artificial intelligence 1. So I could enter E for easy and choose BFS for my algorithm, and that's it. You can see the result and you can see every details of every steps. Now I'm going to show my successor function, which I called as successor to queue. It takes root, parent node, and accumulate cost as parameters. For root, it is a problem itself, and for parent nodes, it's the parent node so that we can know what child states we can go. And accumulate cost. For example, uniform core search will need accumulated cost to choose the minimum cost of paths to go. So in BFS or DFS, we don't need accumulate cost. So the idea was that I try to find the index of blank first, then see what possible states that the current states can go. And then after finding all possible states, I will use a for loop to create the possible states we just found. And if the states has not explored yet, I add them into the queue. I'm going to describe how I implement the search algorithm. Also, I will describe how I insert or remove nodes from the list from the queue. So first, BFS. I created a parent node to store the problem itself, and I do a while loop for keep expanding until initial state reach goal state. So and in the while loop, I would call successor function and add the child nodes into the queue. And in the end of the while loop, the parent node will become the head of the queue, and that queue will also be killed in the queue because using the DePaul method. And after that, I will reset the explore counter to 0 for other algorithm. Let's take a look at DFS. Everything is pretty much identical except this one. Because in depth first search, we need to move children node in front of the current queue. So I would move nodes in queue into a success queue temporarily, and after adding a child node into queue, I will put it out into the current queue, and the parent node will become the head of the current queue. And let's go to uniform call search, and the biggest difference is over here because we need to uh, choose the minimum cost of pass as our next steps. So I have to find the minimum in the queue. So and when I find it, I add to the list and add to the queue. Let's go to best first search. The mainly difference is right here, because in the best first search, program will find the minimum edge of n to be the next node. So in the successor function, I set all the edge of n so I can know what edge of n is in this child node. So I put it into queue. For a star one algorithm, because the algorithm itself uses minimum f of n as a child node to explore, so I would to find the f of n of each child node and add it to the queue.